All right, so here is one of like our class exercise. Can you disprove this equation? So we have here two set a minus b union b minus c. Is this equal to a minus c? So think about just like you can pause the video, okay, and think about like or try to do that by yourself how you can disprove that. Disproof means you have to find out whether the left hand side equals to right hand side, okay, or left hand side is not equal to right hand side. All right, so I'm going to ask you just pause the video, okay, and try to find out whether they are equal or not equal. Okay, so spend around 5 minutes and then spend around 10 minutes, then come back to the video and you can see the result. All right, so here we are going to see like we have a minus b union b minus c. Okay, let's draw them. So what is our a minus b? So a minus b means a not in b. Okay, so this will be our a minus b. All right, what is our b minus c? So b minus c would be b minus c would be our this region and this region. All right, so if we make a intersection of them, which we get, okay, so this is the region, the union of green. All right, union of green and the union of red region is our a minus b union b minus c. Okay, now let's find out a minus c. So a minus c, here we see that a minus c means this is our a minus c. This is the green region is our a minus c. Okay, but what do you think? Is they are equal? It's not actually, right? So they are not equal, so they are not equal set. So one way to do that is you can actually draw the set and you can prove them. But another way to do that also um, like we easily can construct the counter example, and by putting a number in each region in the figure. For example, just give some number. Say this is our 1 2 3 4 5 6 7. Okay, just give some number. Okay, just we are giving them a very simple set with one number. All right, now actually do the calculation, do the set operation. So a minus b here is going to be so we have our a is our 1 2 4 5. Okay, we have our b 2 3 5 6, and we have our c 4 5 6 7. Okay, all right, so this is our left hand side. So you can see that in our left hand side we are going to have a minus b would be, so a minus b would be 1 and 4. Okay, and b minus c would be 3 2. Okay, so a minus b in union b minus c is going to be a minus b union b minus c is going to be 1 2 3 4. Okay, so what about a minus c? So a minus c, here we can see that a minus c is actually 1 2. That's it, a minus c is our 1 2. So we can easily prove that they are not same. So sometimes when we know some rules, okay, so in last couple of slides we actually saw some basic basic law or basic rules of set. Okay, these which are equal to for all every kind of set. So now sometimes we know some basic rules, we can use them to prove new rules without drawing figure. For example, we can prove like that without drawing figure. So a complement union b complement, and the complement of the whole thing equals to, I'm sorry, a complement intersection b complement, and the complement of the whole thing is equals to a union b. Now try to prove that without drawing figure. You know some rules, for example, you know some distributive rule, you know the De Morgan's law rule. Try to prove that using those rules. All right, so here what we have here, if we follow the De Morgan's law, we know that using the De Morgan's law, this will become a complement complement, okay, union b complement complement. Okay, and we know that what does a complement complement means complement of complement a, which is same as a, okay, and complement of complement b, which is same as b. So we can prove that this one equals to this one. Okay, left hand side equals to right hand side. So here we didn't follow any of the figure, we didn't draw any of the figure, we didn't assign any numbers, but using the basic law, basic rules of set, we can actually prove some of this equation. Okay, all right, here I will ask you to again pause the video and try to prove that by yourself. Okay, all right, so what we can see here. Okay, so here what we are going to do, first we are going to implement the De Morgan's law. Okay, so we have complement on both, let's say this one is 1 s1 and this one is another set s2. Okay, so this one looks like s1 intersection s2 and complement of this. So if we follow the De Morgan's law, that will become s1 complement union s2 complement. Okay, so this one will become like this according to the De Morgan law. So a union c complement, this is going to be there we have intersection will become union, and here we have b union c complement. Okay, all right, so we are applying De Morgan's law here. Now again we can apply De Morgan's law actually from in both side, in both operand. Okay, so for a union c, we have complement here, we can actually make it like a complement intersection c complement. Okay, again I'm applying De Morgan's law here. Okay, so I'm applying De Morgan's on the first half, so I can do the same for second half. So b complement intersection c complement. Okay, now what do you see? Okay, I can actually simplify it more. So here I have a complement intersection c complement, here I have b complement intersection c complement. So c complement is actually common in both half. Okay, and for both half we have actually intersection and they are being connected with union. Okay, now if you see, you can actually simplify this using the distributive law. Okay, so distributive law means I can distribute this one in for both a1 for both a complement and b complement. Okay, so in that case this is going to give me the same result. So so this one I can simplify this using the distributive law like this. So a complement union b complement intersection c complement. So that's our right hand side. Okay, so that's our that's our right hand side. That's actually we prove from the beginning. Now that's now we have to look at what is our right hand side. So in our right hand side we can see that a complement union b complement a complement union b complement union c complement. Okay, now there is no way it is they both are going to be same. So here we have A complement union B complement intersection C complement. Okay, and here in the right hand side of our first equation we have A complement union B complement union C complement. Okay, so obviously these two are not going to be same. Okay, so we can say that they are not same, so it means that we can disprove them. All right. So I'm leaving them for exercise and I'm going to talk about them in our problem session. Okay, but please before that try to do that, try to solve them by yourself. Okay, thank you.